Chapter 9, Problem 11. A 75 kilogram adult sits at one end of a 9 meter long board. His 25 kilogram child sits on the other end. A, where should the pivot be placed so that the board is balanced, ignoring the board's mass? And B, where should it be placed if it has a mass of 15 kilograms and it's uniform? So here is our free body diagram. And if we look, we can see that we have the 75 kilogram adult sitting at the left end. So let's call big M 75 kgs here, little m 25 kgs, kilograms. All right. And then we also have the mass of the board, right? But this is changing. Ooh, yes, I'm gonna put that somewhere else. Let's just put it here. MB, so it could be 0 or it could be 15. This is basically the difference between part A and part B, right? So let's talk about the free body diagram real quick. So the full length here, this is the full length of the long board, the 9 meter long board. So L is going to be 9.0 meters, and the distance between, well, we don't really know where the pivot point is quite yet, right? Because that's the question. Where should the pivot be placed if it's balanced? That's why we have this thing here that I put, the variable pivot point. So because we don't know what it is, we kind of have to guess a little bit first, and then with our guessing and with our educated guesses, we can find where exactly this place is, depending on the masses. And so this is a very important feature. So I want you guys to note this is the variable pivot point, this x. It depends on the mass of, well, it depends on every mass in the problem, and you'll see that coming soon. But we have a variable pivot point, and what that means is we can talk about torques around this pivot point, and then we can use these descriptions of the distance, like x and then L minus x, so it's just whatever's left from x after you subtract x. And so once we do that, since we know all the masses and everything, since we know the masses and we know the length, we should be able to find x with all of our givens. And we can't forget the pivot point itself. So I just drew this right under where my pivot point was. It really could be anywhere. But this is going to be the force due to the pivot point. And then you also have the board itself. So MBG is the weight of the board pulling down. The two MGs are the kid and the adult. And FP is the pivot force. And the distance between the pivot and the center of gravity is going to be L half minus x, right? Because the center of gravity is going to be in the center of the board, halfway through the board, so 4.5 meters. But then it's also going to be subtracted by, well, wherever x is will define this distance, right? So we still don't know what x is. That's what we're searching for. So set up the pivot with counterclockwise as positive so that there's no rotation. In other words, this means that, or i.e., this means that the sum of the torques is 0, and then we're allowed to do some very nice stuff. So we have, if we set up the pivot right there, right? So we set up this pivot right here, then FP actually goes to 0, right? Well, FP itself doesn't go to 0, but the torque caused by the pivot itself is non-existent, because to have a torque, you must have a distance and a force acting at that distance, which the only thing we have in the first case in part A is just these two, right? You're tempted to include this one, but in part A, in part B, in part A, MB is 0, so we're actually going to ignore it for now. We're going to come back to it later, but we're going to ignore it for now. So we just have big MG, little mg, and that's going to give us big MG times x. So this is exactly where we had big MG and x distance away, right? From the pivot to big MG, and then from the pivot also to little mg is L minus x, so it's just going to be little mg times L minus x. And then when you do all the algebra for this, you have the right side equals 0, of course, and then you just basically put all the x's on one side and put everything else on the other side, and you should get about 2.3 meters, 2.25 to be exact. And then for part B, we have to just include the mass. This is part B. You have to include the mass, and that just means one more factor, right? So if we go back to our diagram here, from the pivot point to the center of mass of the board is just going to be L half minus x. And so when we include this one, it's just going to be mbg multiplied by L half minus x, which is exactly what I have here. Right? So same process. This one's a little bit longer just because it has more terms after you distribute it, but I promise it's not that hard. You just multiply, distribute all your terms, and then separate x only on this, just like I have here. X things only on the left, and then everything else on the right. Then you can factor out x, divide, and you should end up with the next page's result, which if you do here, you can also factor g out of both the top and the bottom, the numerator, denominator. And if you just plug in those masses, big M was, what was that? 75, little m was 25, and MB is now 15 kilograms. So we have to include that in there. And this should basically change the position to about 2.5. So it just moves 0.2 after